Hello everyone, welcome back to Emmanuel Tutorials. Today we will be seeing a doubt asked by one of the students in the comment section. This is a sketch the signal example and a continuous time one. If you also have any doubts related to signals and systems or any other electronics and telecommunication engineering concepts, please let us know in the comments and we'll try to respond. So here we have a signal as 3r of t minus 3 u of t minus 3. So first part is a ramp and second part is a delayed unit step signal. Now you see that 3 is common in both, so we'll just remove 3 outside and first try to plot the signals which are inside the bracket. So first is r of t. R of t is the unit ramp signal, as you know. So unit ramp signal has amplitude of whatever value it is at t. So at t equal to 0, amplitude is 0. At t equal to 1, amplitude is 1. At t equal to 2, amplitude is 2, and so on. So this is our unit ramp signal. And u of t is the signal, the unit step signal, which starts from 0 and goes up to infinity with amplitude 1. But this is the delayed version. So u of t minus 3 will start from 3 instead of 0 because it's shifting to the right by 3. So u of t minus 3 is the signal. So this is the first part, this is the second part, and we need to subtract the second one from the first. And when you subtract from 0 to 2, you can see first signal's amplitude is just going in the like t at t equal to 0 or t equal to the time instant, whatever is the value that you'll be getting as the amplitude. So that is what I've plotted as it is. So at t equal to 0 it is 0, at t equal to 1 it is 1, at t equal to 2 it is 2, because this plus 0 is going to be the same signal. At t equal to 3, you can see that first signal's amplitude is 3, second signal's amplitude is 1. So sorry, for the first parts it is a subtraction, so even if you subtract with 0, it's going to be the same signal. For the point at 3, at 3, 3 minus 1 is 2, but you can see that it's not a at 4. To understand better, we will see at 4 what will happen. So and 3.5, because since this is a ramp signal, you cannot directly plot 3 plus 1 as, or 3 minus 1 as 2, because it is going to be a step reduction. It's not going to be a direct 2, because if you see here, from at 2, amplitude is 2 and second signal's amplitude is 0, so we have plotted it as it is. At 2.5, first signal's amplitude is 2.5, second signal's amplitude is 0, so we have plotted it as 2.5. At 3, first signal's amplitude is 3, second signal's amplitude is 1, and at 3.5, first signal's amplitude is 3.5, second signal's amplitude is 1. So 3.5 minus 1 will give us 2.5. So that will be somewhere here. So if you see here, if you plot the signal here directly to 1, 2, so this is a decrease, and then it's going again to 2.5. So you have to maintain the shape of the signal here. So we have the ramp, then it is going down, and then again it's going to be a ramp, because whenever you're going to subtract it with a unit step, the signal's shape, or the original signal's shape will change only based on the amplitude, but it will remain the same shape. So we have to keep the original shape of the signal of r of t, but depending on the amplitude change, we'll have to reflect it over here. So here you can see that at 3, first signal's amplitude is 3, second signal's amplitude is 1, so 3 minus 1 is 2. So from what is happening is, it's going to continue with the same amplitude. At 3, there's a sudden drop to 2, and then again it's going to increase. So at 3.5, signal's amplitude is 2.5. At 4, signal's amplitude is going to be 4 minus 1, which is 3. So again, it's going to go to the same slope. At 5, first signal's amplitude is 5, second signal's amplitude is 1, so it is going to be 4. So it's like the unit ramp is again repeating, but it's going to repeat from amplitude 2. So that is what we have here. Hope you got the step. So this is 1 minus 2, and we also have an amplitude scaling. So 1 minus 2, and amplitude scale this signal by 3. So if you multiply it by 3, at 0, first signal's amplitude is 0. So 0 multiplied by 3 is 0. At 1, first signal's amplitude is 1. So it will be 3. At second point, or t equal to 2, first signal's amplitude is 2. So 2 multiplied by 3 is 6. So at 2, our amplitude is 6. At 3, first signal's amplitude is 3. So 3 multiplied by 3 is 9. That's what we have. And then you have to again imitate the shape of the signal, but it's going to go down to 6, because here we have the signal as 2. So 2 multiplied by 3 is 6. Then again we will repeat the same signal with the same slope. So at 4, first signal's amplitude will be 3. 3 multiplied by 3 is 9. So the amplitude is here, and this is going to continue up to infinity. So this will be our final x of t. So it's a it's a ramp kind of signal which is modified, and it will continue till infinity. Hope you got this. If you have any doubt related to this question, please let us know in the comments. We'll try to respond. And if you have any other doubts as well, please put it in the comments, and we will try to put a video explaining that. Also, for specific computer science related doubts, you can watch Ebenezer tutorial on YouTube. Also, put your doubts in the comment section, and we'll try to respond there. Thank you for watching. Please like, share, and subscribe to Manual Tutorials for more. Thank you.